Hello everyone. Today we discuss about interfacing technique in 8085. First of all, there are two different types of interfacing in 8085. One is IO mapped IO, or known as input output mapped input output, where we use 8-bit address, also known as port address. Okay, so in this interfacing technique, first it should be very clear that in this interfacing technique, the data from the microprocessor or to microprocessor from input output device. So here all communication from input output device to microprocessor or vice versa. Second one is memory mapped IO. This is also very important. Why it is named as memory mapped IO? Because we target this IO port, we target this IO port using this memory address. So here we use 16-bit address, because in a 8085 we know that the memory is addressed by 16-bit address. So that's why it is known as memory mapped. That means using this memory mapped or using this memory mapped location, we target our IO device, or we recognize our IO device which is connected through to 8085. So what are the limitations? In IO mapped IO, there are 8-bit port address are used. That's why here we used maximum 2 to the power 8. That means 256 devices are connected individually in IO mapped IO technique. But here large number of, that is 65,536 port devices are connected, 2 to the power 16, which is equivalent to decimal number. 65,536 number of port are selected in a memory mapped IO technique. So this is our first difference. Second difference is that in IO map technique, we used only 2 instructions for data coming out from microprocessor or to microprocessor, coming out from microprocessor or data getting from input output device. So use 2 instructions in and out. This in instruction is used to get the data from input output device to 8085, and this out instruction is used to send the data microprocessor to input output device or port address. Okay, so in IO mapped IO technique there are only 2 instructions are available, but in a memory mapped IO there are lots of instructions are available, like a LXI by which, or LDA by which we can store or we can read the number from the input output device to 8085, and using ST instruction we can store the number from 8085 to IO device. So using STA the data flow is from 8085 to IO, and using LDA the data flow is from IO device to 8085. So here use read bar signal and here use write bar signal. Later will be discussed elaborately. So this is the first topic, IO mapped IO technique and memory mapped IO technique in a 8085 for port interfacing or interfacing in 8085. That means the data, all data are communicated through 8085 or from 8085 to only IO devices. For example, IO devices like a printer, keyboard, mouse, touchpad, any kind of IO devices. This is also known as the human machine interface, because today's technology, this is all are converted to the USB protocol. Also there are lots of protocol are available, like a serial port available, parallel ports are available in a previous computer, floppy disks, hard disk drive. There are lots of protocols are available by which the data is coming or goes to the microprocessor or processor. Okay, so this is a very important chapter of interfacing of 8085. Okay, so first of all, what is the structure of in instruction? So today we only discuss about the instruction. In the later video we will discuss about the hardware concept. Okay, the in is basically the 8-bit port address. Here we mention the 8-bit port address. So what are the limitations? The limitation is port address is from 00 to FF. This in is basically 2-byte instruction. Why? Because first byte is an opcode which is used for in instruction. And second, the port address is a 1 byte data for which we recognize the port address. So basically these are 2 byte instructions. Okay, these are 2 byte instructions. And similarly, in is used for to get the data or to read the data. I again repeat, in is used for to read the data from IO device to 8085. Please note it very carefully. Please note down very carefully. Okay. Second one is out instruction. What is the meaning of out? It is also working for 8-bit port, and these limitations of port number is 00 to FF because it is 8-bit. And first of all, this is also an opcode, this is for opcode, and plus port address. So this out instruction is also 2 byte instruction, 2 byte instructions. Okay. And what is the operation? Using these out, we write the data from 8085 to IO device. So this is the direction of flow. So this is also a direction of flow. This is a read direction, this is a write direction. Okay, this is very, very important. Now we talk about memory interfacing, memory mapped IO. So in the memory mapped IO, we use LDA 16-bit address, say 800. This is a 16-bit address. Okay, this 16-bit address is not a memory address. I again repeat, here we use this 800 hex location as a port address. In the later video, will be shown in the hardware diagram how this 800 hex location is used for to determine the hardware selection. Okay, so now here LDA is one for LDA 1 opcode is required, and for lower byte of memory this is also for 1 byte, and for higher order memory we also get 1 byte. So basically this is a 3 byte instruction, this is a 3 byte instruction. And what is the purpose of LDA? The purpose of LDA is for read operation. How it is read? The data from input device is read to store the data in 8085. That means in the accumulator, because LDA means accumulator. And similarly for IO mapped IO, when you execute in the instruction, then data coming from port address for the corresponding port address, and the data is stored in the accumulator. By default, this in means the data is stored in the accumulator. And for the out instruction, when it comes out the data from 8085 to input device, then the data is placed in the accumulator. Then we execute the out instruction, because out means the data in the accumulator, which is stored in the accumulator, are coming out from 8085 and stored in the IO devices. So this is noted very clear, or note down very carefully, otherwise the instruction is properly not working. Okay. So similarly, the next instruction is STA, say for 8000. So again this is a 16-bit address. So this is similar like a LDA, but the operation is different. STA for STA 1 opcode is required, and here also for 1 byte for lower order memory address, and 1 byte also required for higher order memory address. This is 1 byte, this is 1 byte. So here this is also 3 byte memory location, 3 byte instructions for STA. And what is the purpose? The purpose is for write operation. How it is write? The accumulated data which is stored in the accumulator is stored from accumulated data to 8000 hex. And please remember it, here 8000 is not a memory address. This 8000 is a memory address which is used to selection the port address by 16-bit address lines. Okay, so that's why this is a write operation, because here the data in 8085 is write to input output devices which addressed by this 800 hex memory location. So this is the write operation, very, very important for memory mapped IO technique. So in today's class we discuss about the basic differences, what are the instructions are used, how many bytes are required, what are the operations of these different types of instruction like a in, out for IO mapped IO, and LDA STA for a memory mapped IO. Here instead of this LDA we also used LXI, and instead of STA we also used move instruction from accumulator to current memory location. So in the next video we will show elaborately about the programming approach and the hardware diagram of this IO device programming. Okay.